Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects as well along with the engineering drawing. Do subscribe the channel and get alerts. Now let's see some interesting problems on circular lamina, circular plane surface, making angle with both the reference planes. Okay, now let's take a square circular lamina of size is given, resting on one of its points of the circumference in HP. Diameter passing through the point on which it rests on HP is making an angle 38 to HP and 45 degrees to VP. Okay, so here nothing is mentioned about the surface angle, but he is talking about only the diameter line, and the diameter line is making 30 degrees angle with HP and 45 degrees angle with VP. It's an interesting case. Let's see this. Say this will be one diameter line, suppose, and here it's diameter line is making an angle 30 degrees with HP. That automatically will be the surface inclination also. Now, this diameter line, which is already making an angle, is taken here at making 45 degrees angle also. That means it's a true inclination, but here we need to find the apparent angle. That's why the apparent angle also should be found here. So these are the final projections of the circular lamina. Now this is the front view and top view. Let us see how to draw its projections. Let's take the reference line. Take the circle here in the top view, because the circle is its diameter line is making angle with the HP. Let's start with this one. Okay, so its surface is making angle with the HP. I consider that way. So something is resting on HP. That's why the plane should be taken on the horizontal plane, and in the top view we draw the circle. Show the dimensioning, right? And divide the circle into number of equal parts. Say in this case, we have taken 8 parts here, and 8 points are marked here on the surface. Draw the projectors from all the points and show the front view. So the front view is shown here as a horizontal line, and the points are marked in the front view. Now let's take this surface AE, this entire surface, which is appearing like a line, is taken at a 30 degrees angle to HP. So that means the AE or this entire surface making 30 degrees angle to HP, or even this AE diameter line, AE here, is a parallel to VP, which is parallel to VP is appearing here at a 30 degrees angle. That means this diameter line is taken at a 30 degrees angle to HP. Now let's draw its projections. Okay, the top view. So draw projectors from all the points and draw horizontal lines here from these points. Mark the intersection points, name them, and join them by a smooth freehand curve. You get the curve here like this. Now we are talking about the AE. Why? Because it's resting on one of its points in the horizontal plane of the circumference. So I am considering the point A. So the diameter passing through this point, that means here we have so many diameter lines, but in general we can consider the diameter which is parallel to VP and perpendicular to VP, that is GC. Either GC or AE we can consider. All the other remaining diameters, so many infinite number of diameters can be drawn, but we need not consider them. Here in this particular case, it is resting on the corner, this point A. So passing through this point, we have only one diameter line, that is AE. So AE is already making an angle with HP, and it's making 45 degrees angle with VP also. That means it is the true inclination. It is the true angle, and we have to show that. So because this line is already making an angle, to show that true inclination, we have to find the apparent angle like this. Draw a line here at 45 degrees angle and mark point A and mark the actual length of this diameter AE. So the AE is marked. I call it as E1. So this AE length is marked here, the original length of the diameter. Okay. Now draw a line, the locus of E in the top view. Okay. Now take this AE as radius, this shortened length AE as radius, A as center, draw an arc. This intersects here the locus at a point here. Call this as E. Now join AE. AE is joined here, and this is the actual apparent angle. That means this AE is now appearing at this beta angle, even though it is making only 45 degrees angle with the VP. This beta, this AE line appears at beta angle, that is apparent angle. So once you find the apparent angle, we reproduce the same top view here by taking these 2 points as reference. From A, take AB length, and from E, take EB length, and draw arcs, 2 arcs. That's how you get point B. Likewise, you get all the other points. Join all these points by a smooth freehand curve. That means we are reproducing the same top view here. The same top view is reproduced here such that this AE has now come to this AE position at this beta angle. Now, the top view is ready now. We have to draw the front view. Draw projectors from all the points here in the top view and draw horizontal lines from these points. You get all the intersection points. Join these points by smooth curve, by a smooth freehand curve. Join all the points. We get the front view like this. So here, this is a typical problem to find the apparent angle in this case. True inclinations with both the planes are given, and we have to find the apparent angle. So this will be the final front view and the final top view, the final projections of the circular lamina. Let's take another one. A circular lamina, diameter is given, resting on one of its points in the HP point. Its surface is making 30 degrees angle with the HP. Okay. Its surface is making 30 degrees angle with HP and 60 degrees angle with VP. It's a typical case, right? Already we have seen in the previous examples in one video, we have seen that if you take a line here, a plane perpendicular to this, then this angle will be automatically 60 degrees because this is 30. This will be 60 degrees automatically. That means if we turn this entire plane surface by 90 degrees, this entire plane will become, if you rotate this like this, right? This point comes to this position and turn by 90 degrees, automatically this plane will be making 60 degrees angle with the vertical plane. So we need to rotate this by 90 degrees. In that case, and also one more condition is given that one end of the diameter is resting in HP. So if you see this in the front view, this point is lying in the horizontal plane. The other end, right? For this one, the top view will be here. And the other end is in VP. For this diameter line, this point is in the vertical plane. For this point, the front view will be here. Okay. So let us see. The circle appears like this in the front view and top view. Let us draw its projections. Now, take the reference line, draw the top view here, so that because we want the surface inclination with the HP first, right? This also can be solved by taking the plane in the VP also, that we can discuss later. So here the plane is taken in the horizontal plane. Okay, show the dimensions, mark the points, mark them, and draw the front view. Mark the points here, and now take this line here at a 30 degrees angle and mark all the points here, A, B, C, D, E. Draw projectors from all the points and draw horizontal lines here from these points and you get the number of intersection points. Join them by a smooth freehand curve like this. Now we are considering this diameter line AE. AE is making an angle 30 degrees with HP. So let's rotate this by 90 degrees such that, okay, let's rotate this by 90 degrees here and take this A here and E here. This is rotated by 90 degrees and this point E here comes and touches the reference line. So these two will become the reference points, and now we will draw the same top view here in this new position. That means actually we are rotating this by 90 degrees, okay, 90 degrees counterclockwise, and moving this point E to touch the vertical plane. That's it. So mark all the other points, join them by a smooth freehand curve. You get the same top view here in a new position, such that the diameter one end E is touching the reference line, that is vertical plane. Now we have to draw the front view. Draw projectors from all the points, draw horizontal lines from these points, mark the intersection points here, right? A here, A dash here. So this point will be A. So likewise, this is A dash, A in the front view, A dash. So likewise, get all the intersection points like this, join them by a smooth freehand curve, you get the front view like this. Okay, so in this position, if you observe, the point A is in front of VP in the top view, but it is in the horizontal plane. In the front view, we can see that this point A is in the horizontal plane. That is what we want. Diameter one end is in HP. A is in HP in front of VP. E is, if you see this in the top view, point E is in the VP, vertical plane. Okay. And if you see this point in the front view, it is above the horizontal plane at certain height. This is here. Okay. Actually, if you imagine that if you are looking at in the side view from your right hand side, and if you imagine the vertical plane here, right? This front view will be this one. Your front view will be this one. And if you just imagine a vertical plane here passing through this point, that will be the final position of the plane. That means when you are looking in the front view, the circle appears like this. And when you are looking from the top, this circle appears like this. So the point E is in the vertical plane and above the horizontal plane. That's how we get it. So this is one typical problem on circular lamina, circular plane surfaces. Okay, next. So you can show both this same diameter line in both front view and top view, because we are given this as a reference. I just have highlighted that point, that line. Now let's take another one, a semicircular lamina. It comes under circular curves. So let's take a semicircular plane surface, a lamina. Diameter is given. Resting on its diameter line, the diameter line is in HP. It's a surface making 45 degrees angle with the HP. Okay, surface is making angle with the HP. And so let's show that this is the semicircle, right? This semicircle is shown here, and only we have taken a half of the circle. Its front view appears like this, and the surface angle is shown here, 45 degrees angle with HP, 45 with HP, and this is the diameter. This is the diameter. This diameter is making an angle 45 with VP. So this diameter is now taken at 45 degrees angle to VP, and this front view appears like this. So this is the top view, and here is the front view. So like this, we will be getting the projections. So semicircle is seen like this in the front view and like this in the top view. Let's draw its projections. Draw the reference line. Draw the semicircle here in the top view, such that why we have taken it in the horizontal plane is We want it in the horizontal plane. The diameter is in the horizontal plane. So the diameter should be taken perpendicular to VP. First condition. Second, it is resting on HP. Take the plane in the horizontal plane only. Its angle, surface is making 45 degrees angle with HP. So that's why we have taken the plane in the horizontal plane. So in the top view, that's why we have drawn the semicircle. Now show the dimensions. Mark these points here on this curve, and AE is the diameter. Now draw projectors from all the points and show the front view here. Mark all the points, and now take the line here at a 45 degrees angle to HP, such that this AE is an edge. AE is the diameter line. This AE is now in the horizontal plane. So the diameter is in the horizontal plane. And C is, of course, is raised. Draw projectors from all the points, draw horizontal lines, and mark these intersection points here, A, B, C, D, E. Join them all by a smooth freehand curve, except AE. AE is a diameter line. Okay, it's a straight line. Except that all the other points are joined by a smooth freehand curve like this. Now, if you see this AE is perpendicular to VP. It is a line here. It is in the horizontal plane itself. That means this AE is perpendicular to VP, 90 degrees to VP. We want this at a 45 degrees angle with VP. And that means it is given as, it is this line AE, the diameter line is making an angle, means it is the true inclination. We will see the true inclination, because even this 90 degrees is the true inclination, perpendicular, because this AE is in the horizontal plane. That's why this angle, whatever you see for this AE edge, is making an angle true inclination. So let's take a line here at like this will be tilting, rotating the semicircular plate. So this AE edge will be at 45 degrees angle. So to draw this, let's take a line here at 45 degrees angle and draw this, take this AE edge on the 45 degrees line. With these 2 points as reference, we get all the other points, B, C, D. Now, to get the front view, draw projectors from all the points and draw horizontal lines from these points here. Mark the intersection points. Join all the points by a smooth freehand curve except AE. AE is a line, diameter line. So AE is drawn by a straight line. All the other points are joined by a smooth freehand curve like this. So this is the projection appearing in the front view, and this is the projection in the top view. So even the semicircular planes are given. We can show the dimension, the projections like this. Okay. Hope you had understood this topic very well. And if you have any queries or any doubts, please do comment, like, share, and subscribe. Thank you.